Alrighty, this is the video for Lab 3. So in Lab 3, we are going to be looking at Chapter 5 material, which is probability. Now, again, in this lab, you do not need StatCrunch. Everything will be done by hand and with a calculator. So you do not need StatCrunch for this lab. You still have to have a computer, right, to submit your work on Blackboard, and you need your lab manual, but you do not need StatCrunch in this lab. Okay. So I will let you read this part on your own. Let's think about this lab specifically. You are a statistician working for an insurance company. You're working for an insurance company. So this lab is from the point of view of the insurance. So whenever we deal with these probabilities and profits, because we're going to be examining the profit for an insurance company, we're thinking in terms of the insurance company, not the passengers. We're looking at a cruise. So we're not thinking about from the POV of the passengers. We're thinking about the point of view from the insurance company. So the insurance company offers an insurance package. You know, when you travel now, you're often asked if you want to purchase optional insurance. So the insurance company that we work for, we offer an insurance package to the cruise passengers. For simplicity, we're just going to assume that all customers purchase this insurance. Okay. The cruise, this will be stated on the next slide. The cruise costs $3,000. Actually, we'll get there. We'll get there in just a second. Okay. When statisticians, we're looking at probability, we're thinking of future events. What's the probability that this happens? We need to estimate a probability for an event. So there is a chance that a passenger misses the cruise. If a passenger misses the cruise for any reason, the insurance company, we will fully refund the cost of the cruise to the passenger. But how likely is that to happen, right? That's what we need to be thinking of. How likely is it that a passenger misses the cruise? If a passenger makes the cruise, the insurance company keeps the money that the customer paid for the package. Okay, so two scenarios. A passenger misses the cruise or the passenger makes the cruise. Okay. Depending on how much the insurance company sets the price of the package, we want to see, are we actually going to be generating a profit or will we be losing money, right? If we don't price the insurance high enough and then we have to give all these refunds, we may be losing money. So we have to find that balance. Okay. So as a statistician at the insurance company, you estimate 5% of passengers will not travel for personal reasons. Okay. If we look, so you'll do this in lab, you'll start by drawing a tree diagram and then filling out some tables. Before you collect the data, you'll complete the tree diagram and then fill out table 3.1 and 3.2, and then you'll actually collect the data. Okay, in the tree diagram, we're going to let P, the event P, a customer, and your lab instructor will help you with this as well. So I'm not going to walk through the entire tree diagram, but I'm just going to set things up for you. So a customer makes the cruise. So the probability of P, let me change this actually, maybe not makes the cruise, because we're going to have a conditional. So a customer is able to travel. They're able to travel for personal reasons. Well, 5% of passengers will not travel for personal reasons. So the probability of P must be 0.95, right? Because P complement, the customer is not able to travel for personal reasons, is 5%. And we know that P plus that event's complement must be 1. And so we get this. 4% of passengers that can travel for personal reasons will not make the cruise because of flight delays. Well, if C is they are on time for cruise and they make the cruise, they get on the cruise, then C complement, they miss the cruise for flight delays. So you should recognize that as a conditional probability. They can travel, but then they end up not making the cruise because of flight delays. So this here would be 4%. And then you can calculate the other pieces based on this information. The cruise costs $3,000. We don't control that price, but we do control the price of the insurance package. So we set the insurance package to $350. Is this a good cost? Are we going to be generating a positive profit, right? What exactly does this mean? The first scenario, if a passenger makes the cruise, we profit, the insurance company will profit $350. We do not have to issue a refund. The package costs $350, so we do not have to issue a refund. The second scenario, a passenger misses the cruise, whether they could not travel or they could travel, but their flight was canceled or delayed. So either of those two situations, they missed the cruise for any reason. Well, we gained $350 because of the insurance package, but we have to pay the full cost of the cruise, which is $3,000. So the profit here is $350. That's what we gained from the customer. Now we have to issue a full refund of $3,000. So the second option for profit is negative $2,650. So we're losing money here. If the passenger misses the cruise, then the insurance comes into effect, right? And then we have to pay. We lose profit. So using this information, you will fill in tables 3.1 and 3.2. In table 3.2, we have these two outcomes, and you'll assign probabilities to these two outcomes. And you can use this using the tree diagram and then 3.1, which you will do in lab. Yes, we lose a lot of money here compared to a profit of $350, but how likely is it that we lose money? It's probably not very likely. So if it's not very likely, it should be okay. That's what you'll calculate. Okay, after you fill out those three tables and figures, then you will collect the data. And then again, if you get in groups or groups of 2 or 4, or 2, 3, or 4, this will go quicker, collecting the data. So you're going to look at 25 passengers or 25 trials. You will have two buckets each with beads. You're going to start with bucket 1. So this is labeled a passenger can travel. It should have 19 green beads and 1 red bead. That red bead represents the 5% probability the customer cannot travel. So there's a 5% chance that you draw that red bead. If you draw the red bead, that passenger cannot travel, and then you'll put that they missed the cruise. If they can travel, if you draw a green bead, you'll go to step 2. You'll go to bucket 2, and then draw 1 bead from there at random, right? So don't look when you draw. 24 green beads, so those are good. 1 red bead. They can travel, but they have a flight delay or a flight cancellation. If you draw a red bead from either bucket for that trial, you'll put that they missed the cruise. If you draw 2 green beads, you'll put they made the cruise. So this is table 3.3. Each trial, you'll start with bucket 1, and then you'll go to bucket 2 if you need to. If you get 2 greens, they made the cruise. If you get a red from either bucket, they missed the cruise. Okay. Then you'll go to table 3.4. You'll put the percent that made, the percent that missed. You'll calculate the main insurance company profit per passenger. You'll do that using the probability concept seen in lecture. There's also the lecture recall in the manual. And then your lab instructor will collect all the data for the entire class. You'll put this in table 3.5, so this is for the entire class. And then you'll compare this with the theoretical probabilities calculated before you got the data. So does it make sense based on what was calculated before you collected data? Is the profit positive or negative? Is it close to the theoretical mean? So you'll collect data, you'll see what result you get, and then you'll compare it to what you should get based on the theoretical mean. Okay, then you will answer the discussion questions and submit your work on Blackboard.